welcome to BBC Radio 1. Today we're interviewing Dr. Cook, ophthalmologist. Welcome. Can you please tell me the structures and functions of the eye?
Well, thank you for being here. As we all know, vision is the most important sense of all. And it's divided into four major parts: the cornea, the lens, the retina, and the pupil. The cornea, it's the round transparent barrier that emits light into the eye. The lens focuses the light of the eye into the brain. The pupil controls the amount of light into the eye and constricts and dilates and constricts the pupil, And the retina receives information to the rods and cones. And within the retina, there are millions and millions of rods and cones in both of our eyes. The rods, are sensory cells that are sensitive to light, and they work best in low light but have low acuity. Acuity means that they have low sharpness. The cones, on the other hand, are also sensory to light but work better in bright light and have a high acuity, so they are very sharp. Now, there are other parts of the eye that we should know about. They're important. The optic nerve is the nerve that carries the visual information your eye takes, and it transports it to the brain. The optic chiasm is the place where the optic nerves cross, because if you didn't know, what you perceive in your right eye goes to the left side of the brain, and what you perceive in your left eye, goes to the right side of the brain. So the optic chiasm is where the path crosses. Then we have the fovea, which is a small dimple in the middle of the retina, which is the sharpest. So I hope that answers your question.
That's very interesting, Doctor. So, can you please tell us some question that we always seem to not understand? Is that what we see is really what we are seeing? So that comes to the question, what is the visual process of the brain?
Well, I used to get this question a lot. And so basically, as we perceive the world and are seeing things in general, the process starts when the stimuli is absorbed by the receptors in the retina, which are the rods and the cones I explained in your previous question. And then afterwards, in a process called transduction, this physical energy is converted into electrochemical energy, or patterns, that go into the brain neurons. Finally, the brain codes these patterns into one-to-one information between the physical energy that you received and you perceived and the nervous system. So basically, the brain's function in the visual process happens majorly in the visual cortex. That's the part of the brain that we can say sharpens the image. It clears some shadows, reflections, it turns your image upside down. No, right side up, because if you didn't know, what we're seeing actually is we're watching it upside down. But this part of the brain makes it right side up, clears some blood vessels, and finally it fills the holes that are missing with a process called confabulation.
Welcome again to another episode of CNN Health. Today we're interviewing Dr. Gutierrez. Dr. Gutierrez, can you please give us a brief discussion of visual capture?
Well, first of all, thank you for having me on your show. And basically, what visual capture is this the tendency of vision of having dominance over other senses. And I'm gonna describe this with the McGurk effect.
Ba 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 ba.
As you see in this video, this is a perfect example of visual capture because the majority of the people who see this video believe that the subject is making two sounds, but in reality it's just making one. Vision is having dominance over other senses. In this case, the sense is hearing.
Welcome to another episode of Discovery Home and Health. I'm with Dr. Santos here, and I have a question for you. Could you please make a discussion about two binocular cues and how the brain uses them to compute distance and depth?
First of all, the first example I'm going to present you is retinal disparity. As we saw in the image, retinal disparity is when your brain compares the two slightly different images into both eyes in order to compute distance. Well, the second example of binocular cues is convergence. As we could see in the image, convergence perceives depth. This refers to the point that the eyes converge inward when looking at an object. The brain notes the angle of convergence, and computes the distance of the object.
And we're back. Thank you, doctor. That was very interesting. Now can you give us two examples of monocular cues?
The first example of monocular cues is relative size. As we saw in the image, if we assume that two objects are similar in size, we perceive the one that casts the smallest retinal image farthest away. The second example is interposition. As we saw in the image, if one object partially blocks our view of another, we perceive it as closer.
We're back here on a new episode on NBC News. We're here with Dr. Matamoros, who's going to explain how culture influences perception.
Well, hello Marco, thank you for inviting me once again. In 1966, Dr. Siegel, Campbell, and Herskowitz tried to prove the idea that living in different environments changes the way you perceive things. For example, African people are used to living round houses and buildings, and we are used to live in boxes and line buildings, so they don't perceive corners in most lines of the buildings. So they have a little different perception than ours.
Interesting.
You can see in the past image, the blue lines represent the corners and angles that Western civilizations do see, but African civilizations have trouble seeing due to a different style of life.
We're back. Thank you for explaining to us how culture influences perception. Now I would like for you to make a brief discussion of brain plasticity related to the visual system.
Well, plasticity describes how experiences reorganize pathways that go in the brain. Long-lasting connections and changes in the brain occur when you learn new things, you memorize new things, or you have new experiences. This is what we know as brain plasticity. Thank you for your attention.